Hello, everybody. Hello, 11, Diablo, Calder. Hello, everybody. Hello. Let's see, Diablo on a 7 stream streak. Wow. Uh, Thank you, man. Plus 450 bugs. No, not bad. Not bad at all. If only the integration with those things didn't break ages ago. Like I used to have an overlay that you could interact with spending um, bugs, but yeah, not anymore. So does the thing work yet? Um, Not quite, but we're getting there. So yesterday I embarked on a. So yesterday I took a serious look at the UDP protocol API. Well, UDP protocol schema structure. And I took a serious look and I restructured it a little bit. But that at some point required me to create the concept of a client ID, which we didn't have. And so I stopped the stream there because essentially everything snowballed into a bunch of refactoring, and I didn't want to do that on stream because I wanted to do that with care and mindfulness. Let's just say that while on stream, mindfulness about the code is not exactly does not exactly come easy. So I wanted to reclaim the brain cycles that you tend to lose while streaming and try to do some good. And I'm actually very happy with the result because the refactoring went amazing. It was actually not even too long. Like it took me maybe, I don't know, half an hour, maybe not even that. And I feel like every single line that I touched improved, came out the other end strictly better than it was before. So amazing experience. Highly recommended. There was a little bit of fighting my metaprogramming, but that was pretty much it. So what does it mean? Well, here's what it means. It means that now we have the concept of a stream ID, which we kind of had already before. It was just it was smaller. It was I think it was 16 bits instead of being 32 bits. It had only 1 bit for distinguishing between I don't know, like voice, and I don't even know what the other stream was even supposed to be. In any case, now it's more full-fledged. We have voice. So ID 0 is voice. That's what we already have implemented. 1 is going to be camera. 2 is going to be screen. 3, I don't know yet. Or rather, I think I kind of know, but I don't want to give it a name yet. So for now, that's how it works. And so the structure is this. User ID takes 26 bits, and then we have 4 bits of the client slot number, and then we have 2 bits for the stream kind, which could be one of those 4. So these 2 things, user ID plus client slot number, make up the client ID. Ooh. So you can see it here in its full glory. It's a U30, contains a user ID and I call it slot, client slot number. So what's a client slot number? Well, long story short, the idea is this. This is not implemented yet, but the plan is that when you connect to a server the first time, you have an account already. So you have a user, but you're connecting to it with a new device for the first time. You will be asked to give a name to your client, and your client will occupy one of those 16 slots. And you can only have 16 of those. So when you want to go above that, you will need to delete an old client that you don't use actively anymore. So that puts some limits on things. So in general, the story is that if we're using a U26 for users, that means that we have at most 67 million users per server. Hopefully, we can survive with that. Then of those 67 million users, each one of them can have 16 clients connected. And then that leaves with off of 32 bits. With this we're at 30 bits. That leaves 2 bits free for the stream ID, stream kind that we use in media, stream kind. And so combine everything together, and that's going to be the stream ID. There we go. I might as well just call it stream ID in here. In any case, so formalize what a header is. Then after that, I created structs for everything else. So we now have a type for open path. Open path is the first packet that the client sends to the server to open a path. Then there's a voice packet, and the voice packet formalizes that it has everything in the header plus a restart sequence number. I think this should be collapsed into header. I think there is no point in repeating this. I think you should visually collapse it into just header. And we said that it's 28 plus 28 plus 4 plus 4, 32, 36. And then we just nuke this stuff. Yeah. I think I'm gonna do this now on. Okay, so that's voice. Then video. So this is where we left because the problem with video is that we knew we needed the ability to chunk, to split a video packet into multiple sub packets. And multiple chunks because we looked at the compression data that we got from macOS using H.265, which is apparently one of the ones that compress the best. And well, it turns out that that's still going to produce frames that weigh like more than 160 kilobytes. So 160 kilobytes is a lot of data compared to what we've been working with up until now. And it definitely does not fit one of these tiny UDP packets. So everybody and their dog was telling me that I should not be letting my packets grow past MTU and that I should just do the splitting myself. Well, now we can. I mean, we would need to have this concept regardless to how to which size we cap a packet, because we still have the need to do that. Like even if we were to use 64 kilobyte big UDP packets, well, 160 requires, you know, a few of those. So well, there's that. So this is kind of where we left things yesterday. Oh, and also while I was doing this yesterday, I was also theory crafting a resend video chunk request that the client could send the server. I don't know. This is I don't plan to implement this yet. This is just theory crafting, but you know, why not? I don't know. We'll see how it goes. So, where do we continue from here? So yesterday I was trying to have the webcam produce a video stream, but I think I'm gonna give up on that momentarily, and I'm going to pivot to screen sharing. One reason is that screen sharing is more useful. Another reason is that um, what happens if a chunk does not make it to the client? Yeah. Well, right now you're kind of fucked because you're not going to be able to reconstruct the original packet. So I don't know. You just throw it into the trash as lost. In the future, the idea is for screen share at the very least. So I can answer this question for screen share with greater confidence that I can answer it for webcam. Webcam is more complicated, but although this answer will apply also to webcam, just maybe not to the same exact degree that it does apply to screen share. But the answer is, well, if you see a missing chunk, you ask for it again. You ask the server for it again. It's the only thing you can do. Like the only thing you can do is just ask for it again, and then pray that it arrives on time. And if it arrives on time, great. If it doesn't, fuck. As simple as that. Also, I have no idea how to I have no idea of how to make these packets like how you're supposed to glue them. Well, I guess the first packet tells you how big it's supposed to be. I don't know. Anyway, so as I was saying, so I was doing webcam, but I want to change that because webcam has one thing that makes it too complicated for me for now, and that is that webcam has a hard requirement of keeping audio in sync with the microphone. Screen share doesn't have that requirement. Screen share is out of sync with the microphone. It might carry audio, so the screen share will carry audio, but it's not as problematic. And that audio will have to stay in sync with the video, obviously, with the screen share. But it's not as problematic. So I basically want to leave webcam for last because that has interactions with how the jitter buffer currently works. Yeah, I was. I mean, I should do a better job at publicizing my OnlyFans. I don't know why I don't tell people. Okay. So here's what I'm gonna do now. I'm going to take the compression code that we had for the webcam, and I'm gonna essentially copy paste it over to the screen share code, and then here's what I'm gonna do for now, just for simplicity. The moment you turn on screen share, we start sending it to everybody, and the moment you start receiving screen share, you start displaying it. Although that doesn't tell us it doesn't solve like parameters because we don't know what kind of screen share it's going to be. Like we don't know if it's going to be H.264, H.265. Although, you know what, just for the sake of making progress, we could hard code these choices. Like we could temporarily hard code everything to H.265. We assume that the zoom is going to be H.265, and we just played it. We played as 1080p, H.265, 1080p, 16:9, H.265, 30 frames per second screen share. Just hard coded as that, and just so that we can have it working. And then we build more life cycle around it. Okay, I'm on board with my own plan. Um, let's go do it. So webcam has some code that we wanna yoink. So compression session ref selected codec. Yeah, you guys are coming with me. Screen capture. We might need also AV foundation, but I'm gonna wait until I see a complaint about it before doing something. This the init is not great. AV1 could be cool, but as far as I know, it's not widely supported. A lot more computationally heavy than HEVC. Yeah. So here's some interesting information about this. I started looking into it. So we do have a vested interest in wanting to upgrade to new formats, mainly for one reason. There is a thing that new formats do that is good for us that Neurosite mentioned in passing in the past, and that I looked more into it. It's called SVC, scalable video cropping, coding, compression. I don't know. But the idea is this. I think it is a scalable video. In any case, the acronym is SVC. And the idea behind SVC is that you make one stream. So you ask the client to do is when you gradually degrade quality. Yes, it's when you basically have one compression stream that is internally split across. I think you can do it for frames. You can do it for resolution. There might be a third thing that I don't remember what it is, but in any case, you can do SVC for frame rates. So you have a stream that you split into um, it's one stream that it's at maximum quality is 60 frames per second, but then you have to tell the encoder to do this properly. But you can tell the encoder to say, okay, let's design this stream as two layers: the 30 FPS layer, and then an optional, let's say plus 30 FPS, like an optional 60 frames. So that means that whoever wants to see 60 frames per second has to receive both kinds of packets for both from both layers. But if somebody just wants 30 frames per second, they can receive only the layer 0 frames, and we can avoid giving them. We do not give them layer 1 frames. They will be able to decode the video. They will get a 30 frames per second video. You can do the same also across resolution. So you can have a video that is essentially split into, 1080p, 1080p, 720, 580, or 540, whatever, 580. And so, again, who wants layer 0 is 580, layer 1 is 720, layer 2 is 1080. Who wants 1080p needs to get all packets. Who wants 720p needs layer 0 and layer 1. Who wants 580p? Only layer 0. And you can combine these two things. You can. I think you can do both frame rate and resolution. In theory. The problem is that in practice, apparently, encoders don't really do this, and so it's kind of all over the place. So that is one thing. The other thing is, um, we have an interest. Actually, our primary interest is to be able to use hardware encoders more than anything else. The reason for this is, and then secondarily, I guess, hardware decoders. So the reason for this is, um, whoever does the encoding should not be taking a giant performance hit because they're doing the encoding. It should be as lightweight as possible. That means relying on hardware acceleration whenever possible. On my Mac machine, I can do native encoding of H.264 and H.265. And interestingly enough, let's take a look at this. If I were to buy a to do a Mac Studio, it doesn't have to be the Mac Studio. I think it just needs to be Mac Mini type of thing, or actually a Mac of any kind. It just needs to have a M something chip that is greater than one that I have. I think I have an M2. I have an M2. An M3 has scroll past. What the fuck is this shit? Okay, tech specs. Tech specs. Tech specs. So if you scroll down and you look at Media Engine, this guy can do AV1 decode. I'm guessing in hardware. I'm guessing the reason why they're pointing it here is because they can do decoding in hardware. But interestingly enough, they do not have AV1 encoding. So, funny thing that I noticed, like they do mention AV1. Also, here's another thing that I discovered. Apparently, they're standardizing AV2 in the meantime. So AV1 is not really adopted, and it's already being supplanted by AV2. Then what else did I discover on the subject? I discovered that Ziff has a AV1 encoder. They call it the fastest and safest. The fact that it's safest should make you think. Look at the code. It's Rust. So it's a Rust implementation. I'm not going to comment on the safest, but a lot of people have to comment on the fastest. Apparently, this is not the fastest. There was somebody with a blog post where they were comparing, and the encoder that everybody uses, which is I think it's called SVT AV1. This one is considered actually the fastest. SVT AV1. Which is written primarily in C. By the way, if we end up using this, holy shit, this is going to be another packaging adventure of a C project. If we do this, I suspect this is going to be intense. This is not going to be like for the faint of heart. So there's that. What else did I discover on the subject? I looked into what Discord does, and I saw that Discord on not on my Mac but on another machine. I joined a voice channel and I turned on screen sharing, and it was doing H.265. I'm imagining because that machine supported H.265. I think that if you Google like Discord AV1, people say that they were able to have it work with AV1. No, this is about playback. Okay. Discord rolls out AV1 streaming support for GeForce RTX series GPUs. NVENC H.264, NVENC AV1, 6 megabytes per second. So same bit rate. NVEnc does better. I don't know if they kept it on though. I think I read at some point that they had to turn it off. In any case, I don't know. Good to know. You can now stream in 4K and AV1 with Discord. 3 years ago. Okay. I really like C libraries that have an amalgamated source like SQLite. I find those unfortunate. Those are so. If I were a C programmer, I would 100% share your perspective. I think that is non-controversial, right? Because by being a single source file, they're just easier to use. That being said, it's so sad that those things have to exist, and it's the side effect of the C ecosystem being ridiculously bad. I wish that those things were not a necessity, and that the ecosystem allowed people to build stuff, split normally um, into multiple files in a way that made sense. Also, in a way that allowed them to have namespaces. Anyway, sorry, I'm dreaming. But in any case, it's from a Zig perspective, they're just kind of funny things because from Zig you can build a C project even if it's split into multiple files, and I mean it's fine. But anyway, okay, so what we need is stop. Did stop with error. But we can ask for stopping, can we not? Okay, so Skin Capture Manager unlock, set user data, show picker. So I think that it's fine to leave the init like empty like this. We have show picker. Start capture with filter, that's fine. Add stream output. Did stop with error. Stream. Did output sample buffer. Process video, process audio. Get frame pixel, frame the init. Manager stop capture. Calls stop capture. Perfect. Okay, so we stop capture. And here we do this. Okay. So next, set up compression session. Best available codec. Encode frame callback. Okay, these guys are coming with me. Okay, let's take a look again. So we pick the best available codec. We'll assume that we're gonna do H.265 every single time for now. But in any case, yeah, 1080p, selected codec. Interestingly, frames per second here does not appear because I guess the codec doesn't care. I mean, you are driving by feeding it frames, so I guess it's up to you to decide at which rate you do that. Real-time encoding priority, yes. Constant bit rate of 8 megabytes. for now, I guess we'll see what's a good number here. Oh, there we go. Keyframe interval. Never mind. Oh no, this is how often you want a keyframe. 2 seconds at 30 frames per second. Preferred hardware? Yes. Main auto level. Main 10 auto level. Main 42210 auto level. I guess this is 10-bit auto level. The provided level of the encoded bit stream. Available profiles and levels vary across formats and between video encoders. Video encoders should use standard keys when available and follow standard patterns where not. Okay. So, blah, blah, blah. And this is the encoding thing that we already had. We're missing only one last piece of code, one last piece of boilerplate, which is kicking off compression whenever we receive a frame. Ba-da-ba-bum, ba-da-ba-da-ba-bum. So, show picker, start capture with filter. We should take a look at this again. Start the stream. Did output sample buffer. There we go. So, get the frame, encode it. If instead it's audio, then there's process audio buffer, in which right now we do nothing. Okay, at least we have a print. Okay. So let's take a look at our config here. 1080, sorry, 920, 1080, minimum frame interval 30, pixel format, BG array. Guess that's fine. Probably one of these guys would be more appropriate. But for now, we'll survive, I guess. Ignore global clip display. Yeah, I think this was fine. Scales to fit, true. Show mouse clicks false. Show cursor, true. Actually, those things are all disabled. Audio configuration. Okay, tempo rate 48K. That for sure. Stereo. Oh, this is how you create a dispatch queue serial, huh? Serial inactive. Concurrent. And supports barrier blocks submitted with the dispatch barrier API. Wow. Okay. I think this should be it. We're gonna see what else we broke. Okay, let's see if we build. Yeah, we build. Okay, so we can run it. Is it out of sample rate? Video compression code frame failed. Minus 12902. Uh-oh. So somehow we're failing compression. Interesting, we didn't have this problem with the webcam. We did not have this problem with the webcam. Interesting. Okay, so we're gonna comment out the audio stuff for now. We don't care. Let's focus on what's happening with the video. Is it encode error that we were seeing? We're seeing VT, compression, encode frame failed. This we're seeing. Um, well, to be fair, wait, when am I calling this? Okay, I'm realizing that we never called um, the function to set up this stuff. So there is one more piece of code that we need to copy. It surprises me that we were seeing that message though. But yeah, so in in start capture, what video codec did you decide on? The answer is that the whatever video codec you support, you have hardware acceleration for. That seems to be the best choice. There we go. It's working. Oh, look, these frames are not even that big. These guys are tiny. Look at them. Oh my god, they're so cute. They're so cute. Like that. Let's add some movement. Jesus. Yeah, we're back to 1600K. Okay, so movement bumps it up very fast. I mean, understandably. Okay, so we have video encoding for our screen share stream. Next step, we need to be able to turn this on in a call. So we need a button to turn this on in a call like for real. And we need to send this to other people. So let's add buttons to turn this on. What's the standard? The standard is H.264. That's what everybody has. Then a lot of people have H.265. Not everybody though. And then AV1, pretty much nobody has. So far, I've seen that AV1 is supported by NVIDIA GPUs and by newer Mac stuff. For example, you know what? That reminds me. I'm actually curious. What about this guy? AV1 the code. Video decode engine, video encode engine. The fuck does it mean? AV1 the code. Okay, let's see. So there's no encoding. Oh, they probably added AV1 decoding just to improve battery life on YouTube specifically. Huh. That is an interesting perspective. I mean, yeah, not necessarily just YouTube, but like all the video platforms. Huh. So long story short, AV1 is just software. H.264 has some issues with licensing sometimes. But okay, but who would be affected by those licenses? So you're talking about hardware, right? So you're talking about that some hardware will not have an hardware H.264 or 5 encoder because they would have to pay royalties for that, a license fee for that, right? We as the application, we don't really care, do we? I mean, you could argue that you could try to be an activist, but I think in our case, we grab whatever it's available on the hardware. Like the best thing that we can do for the user is not make them take a performance hit to do video encoding. Okay, so we have this. What was I saying? We need a button. You connect to a channel, and you need a button to start screen sharing, which we currently don't have. Let's go add that. You'll see the garbage that I'm about to make. So how do we display voice channels? We currently don't print pretty much anything in the content of a voice channel, but I don't even know. We have chat panel. Oh, there we go. We have voice panel. It's an empty file. Perfect. Okay. Fab function row VP voice panel. Probably want core. probably want STD, probably want UI. To do, let's see. I just use AV1 as first choice if the hardware supports it. In a project, and fall back to H64. Otherwise, AV1 has better compression anyway. Define what you mean if the hardware supports it. I mean, if your point is prefer AV1 over in the list of hardware encoders, yeah, for sure. I haven't coded it yet, but I would agree that if the machine has a hardware encoder for AV1, we should do that. I agree. Okay, so SCD DVUI. So what should we be drawing? So I think we need, first of all, I think we need a vertical box. I think we need a screen share on, screen share off button. Okay, something like this. Const Awebo. Okay, let's see how this goes. Um, let's see. Are there any concrete plans on scaling for Awebo? I'm asking because Fluxer has problems with scaling in the beginning. I think a Discord alternative definitely has to have it in mind. Trump, can you define scalability problems a little bit better? So question number one. I know that Fluxer is a vibe coded Discord. So let's just say that I'm already not impressed. I haven't looked into it in detail, but the fact that it's vibe coded, and then you're telling me that it's ass, to me it kind of comes with the territory. But so answer this question: is Fluxer self-hosted? Do you self-host your own server? And if so, what scalability problems do you have in mind? Now this is interesting because so we're looking at this guy, but this guy doesn't really have state. Does the does the chat panel have state? Search. The chat panel has search state. But it shouldn't be structured like this. The self-hosting is not open yet, so I haven't tested, but they had problems with their official instance. Fluxer was just an example, though I'm curious how you intend to handle scaling microservices or no microservices, because I can't imagine bigger instances wanting to scale screen sharing, calling, and messaging independently. Okay, so the full picture is this. People have no idea what exactly a machine is capable of doing, especially people that approach these problems by vibe coding instead of doing something new from the ground up. So they don't know exactly what is the amount of resources truly necessary to pull something off. That causes them to overestimate greatly what it takes to do something, and also it makes them accept solutions that are ridiculously suboptimal, but they're fine with it because it matches their expectations. So with Awebo, I have a server running. Keep in mind, this thing is very incomplete, so it's not like really open to the public. But I'm running it on one of these servers. I'm running it on a 2 vCore, 4 gigabyte, €3.49 a month server. These are not like two dedicated vCPUs. These are two shared vCPUs. I haven't tried it yet, but I bet you that this server will be plenty fine for hosting probably even pretty big voice calls. I don't know the numbers for video yet because I'm in the process of implementing it. But just briefly judging at what I was seeing from H.265 encoding of screen sharing, this is probably plenty good. This is probably plenty good also for normal screen sharing. Not games, maybe. Not 1080p 60 frames per second games. I don't know. That I need to check. But for basic stuff, this is going to be plenty good. So to then give you so to finish my answer, the requirements for a chat server in terms of performance, those tend to be ridiculously low, like truly ridiculously low. users, like humans, chat at a very low frequency. If you're in a server that is sending one message per second, like one message per second is already an insane rate for humans. You don't want to be in a channel where people are sending one message per second. It's overwhelming. So then if you have a server that is big enough and there's multiple discussions going on in multiple channels, then maybe you can have one message per second. Maybe you can even get past one message per second. But like one message per second, 2 messages per second, 10 messages per second, these are rates that the crappiest of computers can deal with trivially, absolutely trivially. So for media streaming, the bottleneck is bandwidth and included traffic. 20 terabytes of included traffic means, by the way, 20 terabytes of included traffic is actually enough to run a small server with you and your friends. Even assuming that you do 8 hours of streaming a day, where you're streaming like a video game encoded in H.264, so the least compressed of the encodings, and you have like, I don't know, a dozen people watching you. That is enough. One hosted instance of Awebo equals exactly one server. Yes, Awebo is self-hosted. It's like self-hosted. It's not there's no point in, listen, we already got scammed by Discord once, because if you have a model where it's not one instance is one server that somebody is paying for, then you're getting scammed, because somebody is going to end up selling you Nitro eventually. You know how much it costs in Discord to get 1080p streaming for everybody in the server? It takes 7 boosts. That's 35 euros a month, which is 10 times this server. It's kind of funny. So, yeah, no, like we're not doing that. It's one instance is one server, period. But I'll answer I'll finish answering this. So long story short, you can get pretty far in any case with a single instance, like really far. But if you have a public server, or like you're a famous streamer, I don't know, then sure, it is possible that you run out of resources and you need something bigger. And I have plans for making the multimedia part of Awebo something that you can deploy multiple instances of, and they connect to one central Awebo server that you own. So the idea is that you own all these things. And so that way, the main reason why I'm implementing this is so that you can have different regions. I don't know if you ever had this situation where you're chatting with somebody in Discord and the voice call is not working well, you're dropping packets, you have trouble connecting. For me, personally, it's usually not even being able to connect rather than losing packets. But sometimes that happens. And one very nice thing that you can do in Discord is that you just take the voice call that you're in and you move it to another region. So to have that, and yes, also for some scalability concerns, then I want to basically be able to have satellite servers that you use that only do essentially UDP routing. They just do the media stream stuff. So, but keep in mind, this is not done because one server just can't run a media stream of that kind. That's just not. This is just so not true. Like I'll show you how far you can take one of those turbo crappy servers, because a chat server has so little work to do, just so little work. Of course, if you vibe code shit, if you have a bajillion containers, if you're running MongoDB, if you're running RabbitMQ and Redis and Postgres and Elasticsearch, and then your application is written in Python, and you're doing all the wrong things, then sure, you're never going to be able to run anything half decently on a server like this, and you're going to need a monster server. But if you do things well, You can get so far with so little. For my personal space, this would never have been a problem anyway. I was just curious. No, that is fair. The problem is that people just have no idea um, what it is that is necessary to implement a given like feature that is somewhat resource intensive. We have completely lost this knowledge in our industry. We just don't know. People don't know how big can a UDP packet be. People don't know how much space it takes, or like how much space compressed audio takes. I didn't know that either actually before doing this work. So um, I also never learned. But yeah, replicas for reliability. No, I'm not gonna do that. Not saying that it's necessarily a bad idea, but I'm not gonna do that. I guess so. You do need to have backups, and I'm gonna do backups. Probably spinning up a read-only instance that feeds from the backup wouldn't be too hard, but it sounds like more of an enterprise type of feature than what I would want to worry about in the proper open source project. Okay, let's get screen sharing working. So we are painting a DVI screen share button. Does this thing actually work? Zig build, show me compile errors. There's gonna be for sure. There's no underscore Awebo. Uh-oh. Uh-oh. Werp. Oh, Awebo is not in client. That is fair. Expected 3 arguments found 2. Oh, we don't even get told what the channel ID is. Nor the channel. It's entirely up to us to grab this information, okay? Let's look at what chat panel does. We look at the active host. Yeah. We look at the active channel. Yeah. And then if there is no active call, we return. If there is, we looked at the voice. We make sure that the voice ID is the same as h.client active channel question mark. Is there a better way? Does the channel know its ID? Does a channel know its ID? It does. So we can do c.id. Also, I don't know what frozen is. I forgot. Oh, and we can try. Nice. Okay, see, I think I forgot some stuff. Using live stream, you get that for free now. Yeah, it's backups, but then you need to spin up. I guess what you would want is to somehow have, like, you could do it manually. I guess some people would want to do that in a nicer way. I forgot to answer a question from earlier though. Carton was saying not jumping on the MOQ bandwagon. Um, Not really, because maybe in the future, you could argue that one way of making the sorry, the video streaming more scalable could be, and cheap, could be to, instead of setting up your own satellite servers, you use some MOQ as a service thing from your cloud. In theory, maybe. I don't know. I'm skeptical. I wouldn't mind, like, I wouldn't hate for the cloud to have, you know, managed services that are just plug and play and allow you to scale this stuff up in terms of bandwidth and users and etc. So that you don't have to do any admin work. Uh, but my general impression is that those things are ultimately a scam. Like, they charge you a stupid premium, they keep on shitifying them, um, and then they never fucking do the thing that you actually need. So I suspect that it's more likely that why is this? Why is this at the bottom of my? Oh well. Um, that's my suspicion. I don't know. Okay, so if I click here and nothing shows up, but in theory, actually, we should render something though. I think it's weird that we don't do anything. But in theory, if I join, then this should display the screen share button. Let's see. Never mind. I don't know what happened. And it's also broken. Uh, okay. We definitely have some things to think about. Why are we not rendering this? Okay, let's do this. I guess we want to display this as a growing box. It's a box that takes. I guess we want the empty box no matter what. Okay, let's add the empty box no matter what, because I think that might be good in any case. I think this is how we want it. Man, I wish that ZLS worked. Can we get some new ZLS? Maybe this version of ZLS will support our version of Zig. In the meantime, we can still code from chat panel. Yeah, you know what? Just copy these. Direction vertical, expand both. Oh, and here's how it is. I don't know. Okay, are we? Did we gain? Go to definition? Oh no, we still don't have it. Uh, unfortunate. Oh, this is the server. Okay. Like clicking a voice channel does nothing. That's So this is not how it's supposed to be. Let's go figure this out. I think that we're in channel list. I think we're doing the wrong thing because I think when you click on a chat channel list, if item activated, yeah, we do stuff in here that I bet you we just don't do here. Try CL render voice channel. Right. There's a join button. Yeah, we literally do nothing if you click on the item. Is it where's the menu item that corresponds to voice channels? Oh, don't tell me we don't even do that. No, here it is. Here we do it. Here we do it. Okay. So here we have the menu item, but we're missing the menu item has been activated stuff. Okay. Okay, if the item is activated, what are we doing here? A bunch of stuff that we don't care about right now. We need to do this. Oh, we probably should do this also as well. Oh well. That's gonna be a story for another day. Okay. So now we should have clicking. On macOS, or are you poking poor Windows? Sorry, the actual. I ain't touching Windows. There we go. Join this voice channel to see the controls. And if we join, okay, now we have screen share on. Okay, so now we have the screen share on button, which does nothing, just prints click. Then we can leave, join, leave. Okay, this is all fine. So screen share on. Let's wire screen share on. So screen share on should do this. If screen share ac dot screen share end, screen share begin. Yeah. Um, so there's screen share begin, but there's no screen share end. So let's add it. Oh, but it's a Boolean. Okay, screen share begin, screen share end. Screen share begin. So what do we do with screen share begin? We need to turn on the screen share stuff that we already turned on from the other button. But we need to then push this data to the media sender queue. So in network, we have the media receiver, we have the media sender, and the media sender blocks on. Oh, the media sender blocks on core audio capture packets begin read. Oh, so this guy is currently overly specialized on. It just assumes that it needs to pull from an audio capture packet thing, capture packet ring. Oh, this guy is so cute. This guy is just so cute. Webcam could come before screen share. No, I'm purposely not doing that because webcam is actually more complicated than screen share. Webcam requires synchronization of voice with the video. Screen share does not require that. And basically, keeping the video in sync with the webcam requires approaching the jitter buffer in a different way than what I was doing up until now. Right now, I have a jitter buffer that is very like flexible. Potentially, I haven't programmed it yet, but it's potentially very flexible when it comes to managing latency. With video, you cannot be as flexible because in with just audio, every time you stop speaking and you're silent, then we can adjust the delay in the jitter buffer however we want. But if you, because they're basically you're interrupting your transmission, and then there's going to be some silence, and then you're going to resume at some point, and in the meantime we can, lower the amount of buffering that we do, increase it depending if we were losing too many packets. We can do whatever we want. But if you have a constant, a always on video feed as well, then either you follow the video stream, praying that the video stream stays um, okay all the time, or if you want to do adjustments, you need to reflect those adjustments in the video stream. So the video stream will have to pause, jump forward, or alternatively slow down or speed up faster, like play at 1.25x for a brief moment to resync. I don't know what we're gonna do, but it's definitely more complicated than what I've been doing up until now. So I'm gonna get some practice with dealing with video first with the screen share because it's just less effort. Okay, so we have this beautiful packet ring. The problem is that this is a this is a media packet ring, and I guess the good news is that what we could do is every time we wake up, we look into this packet ring, and then we also look at a second capture packet ring, or we make this generic in the sense that um, we make this ring contain pointers. Man, video is definitely annoying. Or alternatively, well, no, we cannot have the video call back, do the networking. It's that's too much. I think we're gonna need a new packet ring. We're gonna need a, I don't know. This is a essentially an audio packet ring. We're gonna need one for video. Hmm. Yeah, look at this guy embedding all the data in it. Hmm. Okay. I think we need to generalize this capture packet ring into a more generic packet ring. We need a more generic packet ring. Begin read, commit read. This reads only one thing. Oh man, we're gonna need also to change this to read as much as it's available. Hmm. Hmm. Yeah. Okay. We need a packet ring also in screen share, and then we need a network thread to pull from it. Mm. Okay. Screen capture. So right now there's a new frame. Then we're gonna need a packet ring, capture packets, packet ring of what of video frames. Hmm. Okay, there's some work that we need to do. So we need to make a. Shall we try to make a generic packet ring? I think at this point it might not be a bad idea. Okay, I think we need to make a packet ring and we need to make it generic. So we have a ring buffer in here. And in here we have a capture packet ring. So capture packet ring, I'm going to copy it into this packet ring. And then we're going to make it generic. And I think the capture packet ring will become a specialization of packet ring. Also, we need to be able to read more than one thing at a time. Yeah. Mm-mm. Okay, let's make this generic. So this is going to be a packet ring. Oh, you know what? We cannot make this. This now needs to be different. That's unfortunate. So let's see. Mm, buffer len ring index. Buffer len. And it also needs to be parameterized. Okay, let's do this work. So pub function. So this goes away. Packet ring. See you. Okay, T type, then len uh, cap for capacity. That also should be comp time. Capacity. So that means the ring index is going to be an integer fitting range. Actually, we can do it like this: return struct. I think this is going to be a problem. Hmm. Hmm. Okay. Capacity, ring index. So, okay, these are the constants. What's in here? This. Data is going to be capacity of T. Then there's going to be a read index and a write index. This specific implementation of data in this context, we don't care. Empty is going to be this. Yeah. Right. Pointer to T. Let's see. Actually, these guys, these guys have to go in here, of course. Let's also change the order because you care about data. So begin write, packet ring. Um, okay, W plus capacity. Plus one. Begin write. Okay, this is fine. Then also empty has to go inside. Then read. There we go. Begin read, commit read. Okay. I'm gonna delete this test. It's too specific. Okay, so this is a packet ring. Data silence. Read. Why are we doing this? No. Data is just data. And data is a pointer to t. Oops. Okay, this is like very simple. This is very simple, but it should work. So now the type is generic, which is good. Uh, it might be worth zeroing this thing instead of setting it to undefined. Hmm. Hmm. Uh, we could do init splat. We could do like init. I mean, some manual work could be done by us no matter what. What would be a good API? You know what? Let's leave the API as simple as that for now. And then we worry about the rest at another point in time. Okay. We have a packet ring. That means that we can go in screen capture now. We can say, okay, this is going to be a packet ring of what? Now, this is where things get funny. This is going to be a packet ring of what? I guess in our case, the type is going to be a union that either points. No, I think it's a struct that points at some growable buffer, which we could make an array list. Although, no. Although, yes, I think it's. I think an array list is exactly what we kind of want. Hmm. There's either going to be an audio frame or a video frame, and then it's going to be data, which is going to be an array list of bytes. And then I mean that's kind of it. Duplicate member frame. What is already a frame in this context? Oh. Hmm. Call it a packet. Okay, the only problem with this is that I really kind of would like a splat init. Init splat. Give me init splat. There we go. Okay. So the next problem is that we need to rename this function from this file from uppercase packet ring to lowercase packet ring. Um, for sure. You know what? I'm gonna rename this to capacity and then this to cap. Okay. This is not bad. Although in reality, I think we would like this to be better because we would like for every audio frame to be already to already have some data. So I think we would like on initialization. Do we have an initialization thing? Yeah, we do. So we like packet dot data. Also, I think that maybe we should call this buffer. So this is buffer, and so that we can have data ourselves. I think this is better. Yeah. Packet dot data like ensure unused capacity or total, something like this. And then let's make it big enough at least to hold compressed audio data. So that would be like 250 bytes. We saw that most video frames were like 500 bytes, but we might as well put these guys up. Hmm. You know what? Now I'm dubious because if we have an upper bound for how big a frame might be, hmm, then what we can do is um, just have one contiguous chunk of memory and keep using that. Let's grow this up to 200K. Okay. Also, how much buffer do we have? 10? 10 is a lot. Oh, I think we also want length to be a power of 2. Do we not? Are we enforcing this? Capacity should be a power of 2. I think we have this in ring buffer. Okay, let's say that this is going to be 8. What am I doing? Okay. This is actually making me think that, in theory, this shouldn't need to be a separate pipe. We could have one that is shared by everything. Like we have one ring buffer that we use for everything. We use for the microphone. We use for audio from screen share. We use for um, video from screen share. Same with webcam. And the idea is that like Packet could have um, could be the stream ID. Sorry, the stream kind, and then the contents could be audio or video. Huh. I don't know. Okay. Give me a sec. I'll be right back. And then we're gonna continue. I think I'm gonna just keep a second packet ring around for now, and then I'll leave this as a future refactoring. Although maybe that's not a good idea. Maybe just doing it right away is the fastest way to get this going. Yeah, basically we would have to, instead of our coding the stream ID, we just make it slightly, we parameterize it by what we find in here, and then we should be good. Yeah, I'm actually starting to think that this is a good idea. We also need the ability to read more than one thing at a time. So I'll be right back. I'm back. And I have tea. Okay. Yeah, maybe it's time. It's time we do it. Make it nice. Hmm. So we don't do this here. So you guys come with me. We don't need a GPA, but in our active call, an active call has a packet ring. So what's a packet? So a packet will have stream kind, which is not this. Stream kind is gonna be Awebo protocol media stream kind. Voice camera screen reserved. Payload, which is gonna be either audio or video, and then the data. So that's a packet. Just like a media packet. So that's a media packet. And that's what we pump into. We could call it capture packet at this point. Yeah, capture packet. We're gonna have 8 of these guys. Uh, we start empty, but then we have an init function. Do we not have an init function? Crap. We do not have an init function. Well, we don't initialize this. Okay, wherever we are initializing an active call, now we're gonna also need to do this. There we go. Caller is empty. Hmm. Can we try in here? Yeah, we could try. Convenient. Okay. Um, okay, so that means that we also want to go in audio and want to kill this capture packet ring. Want to kill this. Mm, we want to kill this. This guy also had the concept of silence, which I think we were using in network, were we not? Yeah, so we might want to reintroduce, well, we might need to reintroduce the concept of silence in here. We can do audio, video, audio silence, and video. There you go. Solved. Actually, to do it the way that Andrew would like, we would have to do voice, audio, cam audio silence, cam video, screen share audio silence, screen share video. That's 7 values. I mean, whatever. Who cares? Okay, this is fine for now. That's the capture packet. Then what's the next problem? Ah, this is so annoying. There you go. Happy now? Okay, now we were doing core audio capture packets. Oh, this is interesting. When are we locking? Wait, we weren't locking anything from this guy? What? Run host media sender. Core audio capture packets begin read. Well, we should be given this now. Actually, I wonder what we need core for. Well, IO. Okay, that's one good reason. Okay, now we do send, we do put out events. Okay, I think that we need to be given the packet ring. Also, you know what? I think that the definition of a capture packet, I think it belongs to network at this point more than anything else. Okay. There we go. I'm thinking we should give a pointer to the active call at this point. But for now, whatever. Okay, so this guy is happy right now. Okay, audio is not going to be happy. Now these are not a thing anymore. Capture push. Right. Um so when we do call begin, I guess when we call begin, we can save this information inside ourselves, like where we should be putting that stuff. I'm starting to think that the packet ring shouldn't even. I'm really starting to think that should not even be inside the active call. I'm thinking that should be something that belongs to network. Yeah. Yeah, that is something that belongs to network at this point. You know what? It's just so much easier. Don't put it in there. Go in network. Oh shit, network doesn't have state. Then we can give it to core. That's fine. Core. Yep. And then in run. Okay. Hmm. Okay, now this is different. We don't do this. We don't do this. We have core. We do core, capture packets, begin read. There we go. That is great. Um, then in core, when we begin a call, yeah, when we begin a call, not in here, but in core, media connection details, which is when we are actually starting the call. Yes. Okay, so here we reset. The packet ring. Okay. So this is fine. Now if we go in audio, capture push, I believe we still have the problem that we don't know where to put these packets. Do we have core in here? We don't have core. But we can do field parent pointer for core. Anywhere where we do this, here we do it. Core capture packets begin right. Core capture packets commit right. Okay. Okay, so this has been updated to send that information there. Um, Now we need to do the same for the screen share. So screen capture should do that. Ooh. So about that, we don't really have a. We're missing a like a frame push here because we have the Objective C callbacks, but they don't call into our Zig code, and we need to start doing that. Let's see. I'm planning. I'm playing with the idea of building a local message bus to mock SQS SNS. Is there a nice pattern for channels where you might have multiple concurrent consumers eagerly consuming from my queue efficiently? Yes, these things have a name. Um, I think the acronyms are what is it? Uh, Single consumer, multiple producer, MP. No, I think what which one gets put first? I think it's producer first. So SPSC, it's a single producer, single consumer queue. Then you have single producer, multiple consumer queue. And so if you look for literature on how these things work normally, you will find common patterns. I'll be honest, I'm not an expert. In my case, in my case, I either use IODO channel. IODO channel is um, multiple consumers, multiple producers, and it uses mutexes. Um, so I use that in Awebo. And then for multimedia stuff where you cannot afford to use mutexes because you can't do syscalls, then I use atomics. So there's a way where you for example, here you can see that I have a read index and a write index, their atomic values, and I move them around atomically using load and store. You can get a lot more sophisticated though than what I'm doing right now. Here, for example, uh, you might want to take a look also at swap buffers. They're not appropriate for what I'm doing, but a swap buffer is kind of like so one way of doing a channel is to implement the channel on as a ring buffer. Another way is to instead implement it as a swap buffer. That also works. And I think swap buffers have a bunch of nice properties that you don't get from ring buffers. But again, you also lose some. So I remember looking into that at some point, but then deciding to go with ring buffers because they were more appropriate for my use case. Okay, so we have a problem. We don't get called from the OS, and that's bad. So we have We have swap frame. I guess swap frame is our callback. It's just that it sucks because all it does is swap the frame. So we need a swap frame, but then we also need pub function. Um, like a compressed video frame and compressed audio frame. Well, interestingly, for audio, can you even specify compression? I don't think you can. That's actually interesting. Screen capture. Can you say that you want the audio compressed? Okay, what's in a config? Okay, let's start from the top. What's in a config? Configuration preset. Client can use a string configuration preset to create a configuration which suggests values for various cases. Capture HDR local display, canonical display, screenshot local display, screenshot canonical display. Capture dynamic range, pixel format, color space, color matrix. To get HDR capture, rendering on the local capture display. Optimize for rendering on canonical HDR display. For rendering on the local capture display. For rendering on the canonical HDR display. Huh. This is all like this. The main thing that this thing cares about is HDR. About that. That's, by the way, another question that we need to answer. Do we care about HDR in Awebo? If I have to be honest, I fucking hate HDR. It's such a fucking annoying technology. Okay, width, height, minimum frame interval, pixel format. Oh, we know what are the supported ones. 2 plane video range, 2 plane full range, 2 plane full range, opposition float. We should probably pick one of these guys, probably for performance. Full range, maybe, I don't know. In any case, scales to fit, preserve aspect ratio, show cursor, show mouse clicks, background color. Oh, we can set a background color. I guess we could set that to, well, I don't know, whatever. Source rect, destination rect, queue depth. If you now set the default is 8 frames, specifying more frames uses more memory but may allow you to process data without stalling the display stream and should not exceed 8 frames. Wait, what? Wait, let me read this again. Specifying more frames uses more memory. Yes. But may allow you to process frame data without stalling the stream and should not exceed 8 frames. Okay. Color matrix. Should only be used if your pixel format is 420v or 420f. Okay, so guess what? I guess if we're going down that path, then there's some complexity involved. Fine. Color space name. Is this another thing that's complicated? Okay. Captures audio. Yeah. Sample rate, channel count, excludes current process audio. Yes. Ignore shadows display. Ignore framing on windows in the display sharing case. We'll ignore shadows. Capture resolution, automatic best and nominal. Captures shadows only. To capture only the shadows of windows. Why would you want to only capture the shadow of windows? Should be opaque. Ignore global clip display. Ignore global clip display single window. Presenter overlay privacy alert setting. Include child windows. Capture microphone. Microphone capture device ID. Interesting. Capture dynamic range. Oh, that's the HDR stuff. Okay. Oh my god, the syntax lighting broken now, and now I don't understand what's going on anymore. Okay. Preset. Hmm. Okay, so there's just no audio compression whatsoever. It's audio compression is entirely on you. I guess when in doubt, we could just use Opus. Why not? Right? Just make another Opus encoder. Um, yeah. I think that maybe for now we can ignore audio. We can say audio yes, and then we just drop those packets for now. We just ignore them. Let's get the video working first. Also, interesting that pixel format tells you what it supports. PGRA. Yeah. RGB was never part of the deal. Huh. Okay. So what we want is that the compression callback encoder frame callback. There we go. Encode error is keyframe no. So once we get down here is where we have this stuff. Block buffer get data pointer. Data pointer total length. Oh, wait, that also means that, where is it? So audio silence, video keyframe. So we gain another case in here because we also want to say keyframe for video sometimes. There we go. Okay, so Awebo compressed or encoded video frame, and it's going to be user data. We have user data in here. No, I think we don't have shit in here. Wait a second, there should be some kind of user data thing. Refcon, there we go. Compression session create. This is our reference to ourselves. Where is it? Oh, this one. Output callback refcon. So we need to say that it's a bridge self. So we pass down user data. We pass down data pointer. We pass down total length. We pass down keyframe. And that's kind of it. And our job is going to be to copy this data. Okay, total length, I tabooed it. Oh, where did I define my callbacks? Oh, here. Um, you know, you guys come with me. We put these at the very top. I did this for audio and I enjoyed it a lot, so I'm gonna keep doing it. So this is gonna be a void function. Takes in void star. Then data pointer. I don't remember that one. This is gonna be a u int. I guess just an int. This is gonna be a bool. There we go. Okay, let's see what this is supposed to be. Oh, it's just a char star. And the other one is a size t. Okay. So size t. Okay. data len keyframe. Ah, this is not bad. Conflicting types. Okay. Awebo encoded video frame. Then we go in screen capture. Encoded video frame push. Then we're gonna export it. Okay. So this is the callback. And essentially, we would like to go from screen capture to core. See how we do it in audio. Why can I not see methods CLS? Come on. Um, these methods are not pub. They are. Oh, I'm a giant fucking idiot. Yep, that explains a lot of things. There is no data. Oh yeah, I renamed it to buffer. Oh, you know what? It's just a couple of places. Okay. Okay. Now we're in business. W.data data. Yeah. Maybe we should call this bytes instead of data. Oh well, data dot clear retaining capacity. That's the thing, right? There we go. Begin right, commit right. Okay. So with this, we are writing this stuff correctly, as far as I can tell. Read data.len. Right. So now we need to work in network. Now we need to use this stuff correctly in network. We also need to write it correctly in audio. We're not writing it correctly in audio either. Yeah, but we're getting there. Okay. So, also, this is more complicated. Jesus. Um, Let me think. I think we need to dispatch two different functions. So we read a packet, keep sleeping 2 milliseconds until we find a packet. Last, if not the bug, if this is the bug, drop packets, whatever. Okay. Then here we need to look at what it is that we got. So switch read dot data dot kind. If it's voice, we need like to do send voice. If it's screen, we need to do this. Else panic to do. So voice is what we already had. The problem is that we can't just sleep until we're done. We cannot just sleep for 8 milliseconds, can we? No, because we need to consume everything. We need to consume as much as we can. Basically, once we read once, we need to loop as long as we need to do things as long as we can read. Yeah, it's more like this. While core capture packets dot begin read. As long as we ever read, we do stuff in it. Then at some point we will fall off. Uh, Nothing to read. Sleep. Sleep. Yeah. How much do we sleep though? I guess we can afford to sleep for about 8 milliseconds. Like this can be the long sleep, right? Okay. What's below this line will need to go away. This is a const last. Can we do this now? No, last now needs to be var. And we need to update it every time we get in here. No. Actually, more than last, this should be... Yeah, this is like the last loop, and then we spend some time doing stuff. No, okay, I think this is fine. This can be in here, and then that means they can be const. That's fine. Okay. Then this is all code that deals with the voice stuff. We sleep, repeat, begin read. What we're missing is we couldn't read even once, so we need to do short sleeps. So this means var um, uh, nothing found equals true, nothing found equals false, and then here if nothing found, you want this. Otherwise, you want the short one, which I nuked already, didn't I? Of course. Um, Actually, this is the else. Yeah. If nothing found, try io.sleep from milliseconds to. Otherwise, we do the short sleep, loop again, nothing found true, try to read, still nothing. Okay, then we do another short sleep. Okay, as long as we can begin read. Core capture packets, commit, read. Here we're sleeping. We're not sleeping. Let's think about it for a second. We found silence. Well, we're definitely not sleeping here, so we're doing nothing because we want to loop again. Oh, but we do want to continue. Okay. Sequence plus equals 1 was muted equals false. Buffer is this. Packet becomes voice serialize. Read.data.items. Eh, wish this was nicer, but it is what it is. Core audio capture packets commit read. Socket send. Okay. Okay, so far so good. Now screen. For screen, shit. What do we want for screen? We're now at a point where we need to do the chunking. So we need a buffer of the right size, and then we start chunking into it. Ah. Yeah. So we essentially want one of these guys, kinda. Whatever we want this length to be. Then we want that's not voice, that's video. Video does have serialize. It wants sequence. It wants chunk. It wants first of chunk. It wants keyframe. And it wants data. I think that we want I think we want serialize to be different. I think we want serialize to be this is interesting. How do we do this work efficiently? I think so. The problem is this: we're gonna need to produce a bajillion, well, not a bajillion, but we're gonna have to produce like a good number of UDP packets all at once, and it would be nice to do that without waste. So one thing that we could do is have some headroom at the beginning of the buffer. We slap a header there, and then we send the first chunk, and then we slap another header, and then we send the second chunk. The problem with this approach, though, is that we're not going to be able to send all of them at once. I think that the audio thread code that receives data from the OS needs to essentially split this guy into multiple chunks and uh, essentially pre-apply the headers so that we have one contiguous chunk of memory that we will know how to split into multiple slices without allocation, without modifying data, without copying. And then we need to be able to call a function in here where we don't do sock.send. We do sock.send many. And the problem is that those guys need to be a slice of outgoing messages. Okay, so that means that this buffer needs to hold not only our own headers, it needs to hold a bunch of outgoing messages. What's in an outgoing message? Oh, come on. Well, we can go here, we can go here. Outgoing message. Address. Data pointer. Data len. Control. Um, so we can leave writing the address after the fact. How do we do this? Well, we could do it in batches of 64, now that I think about it. Yeah. So we don't put any of this in our buffer, but we do it in batches of 64. Yeah, that is fine. That is fine indeed. And actually, we want to batch not only this guy, but kind of everything wants to batch. And for this to batch, it means writing the header also for this guy beforehand. We can do that. Okay, let's imagine that we batch everything. So how is this going to work? Essentially, in here, we want the batch. So here we have the batch. Then in here, instead of sending this packet and serializing it, let's imagine that it is already serialized the way it should be. So the original data is like this. Oh shit, but this will not allow us to commit the read right away. Ah, that is indeed a problem. That is indeed a problem. We cannot. Oh, this is interesting. Never mind. If we do batching, we need to do it off of our own, like some kind of pool that we already own. So for now, it's fine. Okay, so for now, let's just do the batching below. Let's do the batching here. So we see these. Okay. So if we see these, we're gonna have our batching in here. We're not gonna have a buffer like this, but we are going to have a reusable thing, which I'm gonna put out here. I'm gonna say var video frame video buffer. Okay, video buffer. So every time we enter here, we do video buffer dot clear retaining capacity. Then we want to take the data that is present there, and we want to know how many frames it makes. And that's easy because we know we take the size of a packet, we modulo that number by the size of a packet, and then we do +1. So chunks is going to be read dot data dot items dot len modulo. Let's assume 1280. Well, we need to be precise though. What is our packet size? You know what? I'm just gonna put the number here right now, but we need to make a constant for it. Let us assume that it's going to be 1280. Then we do. Then it's gonna be I guess +1. Then for chunks, okay. For chunk, we will want to do batch at batch idx. Okay. Batch idx is going to be address. Yeah, what's the address? Address is going to be server. Data pointer, data len. Data pointer is going to be read.data.data.items at mm, mm, mm. So chunk ID, we start from 0. I think we want to start chunk ID with 1. I'm burned out as a software engineer. Should I consider developer advocate positions? Um, Generally speaking, probably no. Mm, the actual answer strongly depends on facts about your own life that I don't know. So like if you let's say that you really want to be a developer advocate, then maybe the answer should be yes, you should be a developer advocate, even if there are other issues, like even if the market is not good right now. But one reason why I would say no is that I think that the developer advocacy field as of late is a complete mess. um it generally doesn't do well whenever there is economic instability, and right now there is a ton of economic instability. It's unclear, like US politics, AI, everything is a giant mess. And the developer advocacy, it's kind of a luxury thing that companies really are willing to keep, or rather, it's a stable job only when things are are going well. When things are not going well, it's unstable. On top of that, developer advocacy is something where you make content, as in you write blog posts, and as of late, that also is made more complicated by the fact that there's AI and slop everywhere. And so, in a sense, now the bar has risen because a crappy developer advocacy slash marketing blog post, ChatGPT can make crappy blog posts like that. So for you to be effective, you would have to write good stuff. And that is not really the hard part. The hard part is your managers need to recognize good stuff from slop. And chances are they won't. So they are not going to be able to understand if you're doing a good job, which tends to be a big problem with developer advocacy. Like it's hard for companies to understand if a developer advocate is doing a good job because you're doing something that is extremely high touch, high level, and so you don't really bring in metrics that they can observe, which is the one thing that they tend to understand. Maybe if you're lucky, they would need to understand like it's not a quantitative thing; it's more like a qualitative thing, and that is something really hard for managers to understand. and in turn justify to their, their own superiors. So all of these things make everything kind of hard for developer advocacy right now. That being said, if that's what you want to do, go for it, obviously. But be aware that it's not a career that right now is going particularly well, I suspect. That being said, I've been out of the game for a while. So, you know, maybe what I'm saying, while I do think that what I'm saying is generally true, there might be some niches that I'm unfamiliar with. There might be, some corners of the industry where actually developer advocacy is flourishing, and I just don't know about that. But yeah, last thing that I would say is if you're burning out as a software engineer, it's hard for you to be a good developer advocate if you're burned out as a software engineer. Like a good developer advocate has to be naive enough to still think that you can do good things as a software engineer. Like you can make users happy, you can produce actual value. Not just for the shareholders, but like actual value, like do useful stuff. And unless you have that naivete by tied to your persona, it's gonna be hard. It's really gonna be hard, I suspect. Every time I was offered a DevRel position, one of my first questions was, what are the metrics that will determine if I'm doing a good job in their eyes? Microsoft did some stupid stuff like you hand out Azure vouchers at meetups, and people who after start paying for it are a metric of success. Jesus. The worst part is that when your managers come up with dumb stuff like this, they not only they will not appreciate if you do well, but they will in a sense doom you to failure, because they will put you in a position to become the annoying Azure voucher pusher. That kind of stuff. And also, it's not like Microsoft really needs money from developers that start paying for Azure. Like, whoever told you this is so fucking dumb. I don't even know where to start. Like, Microsoft is not in the business. So first of all, rule number one of developer advocacy: you don't sell stuff to developers. Developers don't have money, or rather, maybe they have money individually. So if you're selling them iPhones, you can sell them iPhones if you want, but they're not the ones that pay for like infrastructure. Somebody else pays for that. They just use it. They have a role in choosing, tool A versus tool B. And so you want them to like your tool more than the competition so that they influence the decision making in the company. But they don't have a wallet. And Microsoft is like, let's say that in the completely absurd case where you go to a meetup, there's like 30 people there, you hand out 30 Azure vouchers. And of those 30 people, all 30 of them start paying for Azure. Now what? Like, now what have you done for the company? Now Microsoft, oh man, whoa, now Microsoft is gonna be fine because now there's 30 developers that are started paying, $20 a month for a Azure virtual machine. Wow. The company is saved. Like, it just doesn't even compute. It doesn't, like, this whole thing doesn't even compute. Oh my god. Developer advocacy being part of the marketing team instead of the dev team is also a huge red flag for me. I think that everything comes with pros and cons. I can give you a long list of cons of being under the dev team. No matter how you slice it, developer advocacy is what do you call it? It's like it's cross-sectional. Developer advocacy developer advocacy is marketing. You cannot do developer advocacy effectively if you don't have an understanding of marketing. Developer advocacy is engineering, and you cannot do developer advocacy effectively if you don't understand engineering. Um, Developer advocacy is also partially customer facing, so you should actually have interactions with the sales part of the company, in my opinion, if you want to do it well. At the very least, marketing and developer is like it's a 50-50 split between the two. I would argue that not being that being involved with sales also helps. There are companies that have developer advocacy under sales. That is also probably not a particularly good fit. But the point is, it doesn't matter where you put it um, in the org chart. Um, there needs to be a clear understanding that developer advocacy is cross-functional, and it's not just one thing. I can promise you, I've seen bad developer advocacy come from a uh, people under dev. But it's a mix. It really is a mix, in my opinion. So there's going to be 5 chunks. We do 1 to chunk plus 1. So we start with chunk ID minus 1 times 1280 up to the minimum between read data items len. And either that or we could advance stuff, but I think this is fine. Until what is it? Chunk ID times 1280. Data len. Oh. Data len, huh? Well, I guess it depends on whether we are on the last chunk or not. I'm starting to think that maybe we should special case the case where we are on the last chunk. Hmm. Yeah, you know what? Maybe we do it like this. We don't do the plus 1. These are chunks that we know have maximum size, so 1280. And there is no mean. Oops, I definitely deleted too much. Oh no, I haven't. It's just too far. Okay. So with this, we send a full batch and we keep looping. And then as we get here, so here we know after that batch IDX is lower than batch.len. So that means that it is guaranteed, um, we have space for one more message. If we get in here, then we want to do batch IDX equals dot, and this is going to be the last one, which is going to have which is going to be smaller. So it's going to be address equals server data ptr equals, this is going to be important. So we can do it like this. Const remaining is going to be read data. Oh, also this is wrong. This is not percentage. This is going to be give me the reminder. That's not what we want. We want to know how many times this can be divided by this. So so this is going to be something different. This is remaining. And then we do if remaining is greater than 0. We do this. Data pointer is going to be read data items. Basically read data items dot len minus remaining to the end. Oh, the PTR, and then there we go. Batch index plus 1. And then here, if batch index is greater than 0, we do one last send many. And we send batch from 0 to batch IDX. I think this can be simplified then. Okay, let me double check. So chunk ID plus 1 times 1280. Chunk ID starts at 0. So we cannot do this. So this needs to be chunk ID times 1280. Yeah, starts at 0, 0 forward, 1280, then 1280, blah, blah, blah. I think this is it. I think this is it. Okay, now we need to count the number of divisions of times you can divide this by 1280. Um, shit. How do we do this? Uh, what's the function? SED math dot um CBRT clamp. Comp time mod. Copy sign. Oh, we have a LERP. Nice. Guess we could do log, but is log what is log going to return? Ah, returns the logarithm of the provided base. Okay. Hmm. Wait. Yeah. Okay. I don't know. I guess it's time to see if this works. Um, I guess we can start to see if we regressed the audio stuff, and then we can try to see if the video stuff works. I don't know. Let's see how are we doing with regards to building. No filling len in core capture packet audio. Oh yeah. Well, we definitely left this in a weird state. So capture push now. Copy simple stuff in here. Yes. In any case, we do write data len, and then we write in there this. All right. Okay. Payload if silence else audio, right? Dot data dot kind is voice. Commit right. Okay. Duplicate symbol definition, Awebo, encode video frame. Encoded video frame. Duplicate symbol definition. Um, so in here, I think we're missing the weak attribute. Okay, so now we're building. Let's see if audio still works. No. Integer does not fit destination type. Int cast res. Oh, well, okay. Wait. I'm noticing mistakes in that code. We do clear retain capacity. Now this is a different push. Okay, let's look at audio first. Do we reset this? We need to reset this, right? Data clear retaining capacity. Items. Okay, not great. Index out of bound. Index a lot. Len 0. Ah, shit. Yeah, I mean, that is true, but man, yes, that is true. Okay, let's do it like this. Test. Test. Okay. So audio works. That was easy though. That's the easy part. Um, next is writing video correctly. Ooh. Let's go in screen capture. So now, clear retaining capacity, yes. I think we need to make it bigger than that. So essentially, the total size is clear retaining capacity, then ensure and use capacity. It's not len, so it's going to be const total len. Total is going to be the number of bytes plus a header worth of data every single time. So it's going to be len plus times header oh man, this is complicated. Okay. Oh my god. So this is gonna be framing size is going to be size of header plus size of video oh shit chunks are gonna be these plus one total is gonna be chunks times framing size plus len, the actual bytes. And that's how much we need to have. And then we can't just append slice. So some capacity is going to be more complicated than that. Do we need a Awebo in here? Okay, and then in here we do essentially it's the same iteration that we had on the other side, except that here chunks is 1 plus. Hmm. Full chunks. Yeah. So full chunks. We want to write the header. And then Jesus. So TTR is going to be w.data.data items. I think maybe modifying this might not be a bad idea at this point. So this is going to be items from chunk ID times 1280 until the PTR, I guess. Well, I guess technically we could do this. Framing size plus 1280. No. Because it's 1280 minus framing size. Well, so it's 1280 essentially. There we go. Chunk. And then for header, we do SCD mem dot bytes as value type media header. Ah, it's just a pointer cast. Interesting. Yeah. Okay. I think Let's do something better. Const header equals Awebo protocol dot header. Okay, and so then we can do header. So on a header, what do we set on a header? Stream ID? Not really, but um, well, no, we set the stream ID kind and the sequence number. Oh shit, the sequence number. We don't know here the sequence number. We don't know the sequence number. We could know the sequence number though. We should know the sequence number. Okay, video. Video has chunk versus chunk keyframe. Chunk equals full chunks plus one. Actually, that plus one we don't know. You know what? We're doing this plus one unconditionally, but we actually don't know. The plus one is given by there being an incomplete. Hmm. So chunk is gonna be full chunks plus okay, so this is the state for video. And then we need to copy data into video into data out. So we write in data out um, data from actually from where to where, from data out dot len times chunk id onward. My math is wrong because I'm not accounting for the fact that we cannot just modify full chunks. The number of chunks is not dependent on dividing this by 1280. This is 1280 minus framing size. Yeah. Chunk ID times 1280. 1280. Yeah, because that's going to be the size of one thing. Okay. And then we need to write the final thing, the final chunk. So if last chunk data greater than Last chunk data is greater than 0. Then when I write the final stuff, it's going to be this. It's essentially the same. We kind of want to do this. It sucks. To the end. So data out. But we cannot use data out.len because this is going to be different now. We need a proxy for this. Oh, well, would you look at that? There we go. Okay, now it's more clear. And then down here, we can do data out, data from full chunk data time chunk ID, which in this case is going to be full chunks. To the end. And in theory, these lengths should match. So we mem copy that. Okay, so in theory, here we have everything. In theory, here we have everything. If I have to be honest, maybe this whole thing could have been done, now that I think about it, in the network, not here. It doesn't matter much because here we're slowing down the writing side. You know what I just noticed? Here's what I noticed. I made one critical change now compared to what it was before, because now we have a um now we have a multi-producer queue, and this multi-producer queue does not work correctly. Huh? Huh? This multi-producer queue right now, as is, doesn't work correctly. Damn. Damn, damn, damn. It doesn't work because we cannot share. Uh, I would need a multi-producer single consumer queue, which I don't have. So no, I mean, so we need to have. So we cannot have just one of these. We need to have more than one, and then we need to pull them essentially from the network thread independently, which is fine, which we can do. But we can cheat. What we can do for now is we add an early return to the um to the audio stuff, and we only let the video come through, and then we fix it later. Yeah. I had to use RabbitMQ because I suck at implementing my own. I mean, that's a big jump going from needing a multi-producer queue to jumping onto uh full product. In my case, I think that the good news is that I don't really need it because I can just make separate queues. Yeah, not meaning to seem like I'm picking meats, but what is 1280 constant through the code? Would it be better as a constant? It would be better as a constant. Yes. The problem I'm not doing it now. Um, but 1280 is essentially the MTU. Actually, the number is bigger than 1280. In any case, around 1280, more or less, is the size of a UDP packet before it gets fragmented by the network. You don't want. I've been told that you don't want the network to fragment your UDP packets because that tends to cause them to be dropped more frequently than otherwise. So um, instead, we do the uh, instead of making UDP packets be as big as they could theoretically be, we keep their size uh, at the MTU threshold. And that's kind of what 1280 means. Although I have some math that I need to polish a little bit. The right number is not 1280. I think it should be a little bit bigger. In any case, I'll make it a constant once I do a polish pass on this stuff. Yeah. Okay. So I think I'm gonna stop here. Unfortunately, there hasn't been anything too exciting yet, right? Because we're still taking the data, splitting it up, turning it into a bunch of UDP packets. I'm messing up the math along the way, but it's not gonna be a big deal. I'm gonna be able to figure it out and make it nice. But we are getting there. So what I need to do is switch back to having one queue per producer so that we can keep using our single producer stuff. The reason why I'm not switching also to multi-producer is because I think that multi-producer requires more shenanigans in a way that um doesn't really apply to our use case. So it's probably just better to have separate queues in our case, and because we can afford that. And yeah, and then we need to make sure that the network code can deal with it, can deal with the stuff correctly. And then after that, um, yeah, I don't know. Yeah, no, this is actually good. So the way that I'm doing it here, this is actually good. And I think that the moment that we are gonna have, you know what, we could even consider having multiple threads for the network, but I think it's not gonna be necessary, at least in the beginning. So I just need to make sure that my math checks out and re-add multiple queues. And then we're gonna be done with the sending side of things. So we're gonna be able to send video data. Now, here's the problem. We still need to write the receiving side. So we need to write code that receives these chunks and that makes them uh it receives these chunks and then basically recomposes one thing, and then we need to display that, I guess. And actually displaying is not going to be hard. Well, we need the coding. We need to take that data, we need to decode it, and then we can display that. So one more step. Need timestamps? I don't have timestamps for now, or rather, I do get some of that from the system, but I'm not sending that information over. Mm, Also, I'm thinking the timestamp stuff. I wonder exactly how much it is relevant because we have sequence numbers. So even if I don't know, the absolute start time, which other machines don't care about my local time, but I do have sequence numbers. So I know that, the let's say the 10th, the packet with the frame with sequence number 10 is going to be 10 frames in. So if it's 30 frames per second, we're 30 frames in, then that's going to be, a given timestamp. So I don't think I'm going to need that. We'll see though. For audio, for example, I have not used timestamps anywhere because we go by the sequence number. We'll see. So chunking sucks, but I guess we're getting through it, and it's not that terrible. Like ultimately, it's slower than a full mem copy, but especially if we leave this guy on its own separate channel, well, yeah, a ring buffer, um, this should be fine. Yeah, this should be fine. Okay. So I would say thank you all for hanging out. And tomorrow, maybe I'll make some progress on my own tonight. We'll see. Probably polish. But tomorrow, we're probably going to have the we're gonna enjoy looking at looking at this process from the other side of the pipe, and I think from there, being able to display stuff shouldn't be too bad. Anyway, thank you all for hanging out, and I will see you next time. Let me see if there's anybody doing Zig that I should raid. Otherwise, I'm gonna be lazy and call it a day. There's Ethernet cable. You know what? I'll raid Ethernet cable. Go say hi, and I'll see you next time.